Hey everybody, in this video we will get started in the movement unit and talk about how you can program the robot to move forward. But first, there is a new robot that we can meet. This is Iris. Iris is a moon rover that is described to be about the size of a shoebox. Iris was designed by students at Carnegie Mellon University, and its purpose is to drive around the moon to collect data for geological sciences and is actually scheduled to go to the moon sometime in 2022. So for Iris to actually complete its task, it needs to follow a written program that tells it to move forward, how fast to move, when to turn, and how much to turn. And that is what we are going to learn in the robot movement unit. You will be able to program TacoBot to move forward and turn. In this video, though, we will just talk about moving forward, so watch out for my next video, which will be about turning. All right, so let's go to the moving forward lesson and open up the first virtual activity. Right away, you might notice that there are measurements on each side of the table. So these are both in centimeters, and it tells you that basically each square is about 10 centimeters. And let's start with step one. So step one says to add a movement block, and I've already done that. So I just dragged a movement block from my block palette and put it in my program. And then step two says to run the program. So I want to watch where my robot is starting. So I'll take note that the robot is starting on the 0 mark, and the center of the robot's wheel is where it is starting. And if I press play, the center of the wheel is now on the 10 centimeter mark. So it has moved forward for 10 centimeters. If you continue on the page, you'll see that you can do triads where you can change the distance, change the speed, and change the direction. So something to take note of is in the second triad, changing the speed, is you have to actually add another block. So this set movement speed is used to specifically set a speed if you want to move the robot faster or slower. And now let's talk about program flow. So in the last unit, we learned how program flow works in a sequence, which is from top to bottom, one block at a time and in order. Well, that is really important to remember here because we were just introduced to a new type of block, a setting block. We used a block to set the movement speed. So in this program, we have a set movement speed to 75% and then move forward for 50 centimeters. Program flow flows from block to block. So the robot learns how fast it should move before actually moving forward. And the order of these blocks is important because if you swap these, the robot would not know how fast you want it to move. So again, it's just important to keep in mind how program flow works. The next page is a mini lesson about proportional relationships. So this page teaches you how you can calculate how far the robot will travel by using the wheel's diameter and circumference. And then we get to the mini lesson, sequential movements. So in this challenge, you are to program the robot to move forward 20 centimeters at a time. But each time the robot moves forward, it should be a different speed. And after each time that it moves forward, it should stop for a second and then play a sound or light the hub. So I can show you how my robot runs this challenge as an example. And I chose to light up the hub after each time that it moves forward. So you can see it's moving forward 20 centimeters at a time. And each time it is set to a different speed. Something that's important to remember is that just like the physical robot, the virtual robot's wheels tend to slide when it's driving at higher speeds. So I can restart this and show you just as an example. If I set my first movement to 100% speed, my wheels will overshoot the 20 centimeter mark. And therefore I'll be overshooting every other 20 centimeter mark. And at the end, I would fail the challenge because the wheels are sliding if it goes too fast. So when you set your speeds, just remember that the wheels may slide. So it might be best to stick to an average or lower speeds. And that's all I have for moving forward. If you have any questions, you can email me at qa@cs2n.org. Bye, everyone.